Welcome, everybody. This is our normal Tuesday morning class. We've got Matt and Larissa here. Nico's traveling today, and Darinka is also traveling. So this, I hope, is the final version of this. The talk's about less than 2 weeks away, so I'm planning on this. This is it. So I changed the title because I looked back at the title I promised to talk to, and this was it. So I thought I better, the thing is sold out a long time ago completely. So I thought I better have the title I advertised. So Challenger and Hubble renewable failures. And there's a lot of people who've written a lot of things. And there's a guy in town in Boulder walks around talking about what caused Challenger. They've all got different versions. I don't think any of them actually get to what I call root cause. And that's what this briefing's about. What is underlying everything? This other guy calls it groupthink. You could certainly say that, but I don't think that's root cause because I think something else is. So that's the game here. And what we're going to do, have a little tutorial here on some of the elements of this kind of social context work, talk about these two failures. And the question is, what happens when well-intentioned, smart people fail to notice whether they're reasoning by analogy or from first principles, which informs their subsequent storylines? And after you leave tonight, I want you to see if you can notice your reasoning, whether you're reasoning by storylines or reasoning from first principles, reasoning from, by analogy. So when I was young, I told my family I wanted to be a comedian, and everybody laughed and laughed and laughed. Unfortunately, nobody's laughed since. That was a joke. So you've seen these slides. I think what's interesting about this is that I've been looking into sort of history of physics for fun in writing my memoir. And the experiments that changed physics are not necessarily ones that refuted what people believed, but the ones that were done with such precision that the results were unassailable. And John Mather, my good friend and project scientist for this mission that my division built, measured the 3-degree background. Those are error bars, folks. This is the power of what he did. And the effort to get rid of all systematic errors in a measurement like this is quite incredible. But it absolutely convinced me and probably almost everybody else that this mysterious background radiation that's everywhere is in fact the flash of the Big Bang redshifted down to 3 degrees Kelvin. And John appropriately got a Nobel Prize for this work. And as you know, the joke from before, John travels around the world and brings his own chauffeur, and they're in a town where nobody knows quite what they look like, and they look pretty similar. So the chauffeur says, let's swap places. And the chauffeur says, I've heard you do this talk 20 times. I know I can do it without any problem. The crowd's cheering. And an astrophysicist gets up and asks him about quantum fluctuations. So he breaks out in a big sweat. And then he points to the audience, to John, and says, that question is so easy, my chauffeur can answer it. So I know you've heard this joke before. So what does it mean to reason by analogy? You're drawing conclusions about something new by comparing it to a known similar situation. And we'll be riding in the car, and Junko does this a lot. So the traffic is heavy because it's Friday afternoon. Well, it might be for that. In fact, it's likely for that. We have no certain knowledge. Engineers reason by analogy. If a certain set of blueprints built a good, strong bridge at a reasonable price, they're probably just using them again. Following recipes to cook things, the assumption is that someone followed that same instruction before and it provided a good result. So by analogy, if you follow the instruction, you will too. And then all this so-called technical analysis, that's 95% of everything I read about financial work. It all is some version of this happened in the past, therefore it's going to happen again. This is so easy. We habitually do this. I catch myself doing it. And it's because it often works pretty well for short-term tactical decisions. If you want to engineer something in a hurry, you're going to go to existing plans. If you're going to whip up a recipe, companies coming, go to existing recipe. If you want to decide whether to trade a stock on this particular day, you might look at technical charts. And it's effective when the analogy is a good one. That's the risk with this. The analogy often isn't appropriate, and it's comfort food for curious people. You feel like you've come up with an answer. Disadvantage is often the analogy doesn't actually match well enough. You shouldn't use it. It can erroneously tell you what's going to happen in the future. Most of this technical analysis people do is about what's going to happen next year, and it's probably wrong. It's anchored in the past. It's by definition, it's not strategic. And it tends to end the inquiry. Once you say that's the reason traffic is heavy, you tend to stop there. First principles goes back to 2,500 years ago. Aristotle talked about this. And it is the modality, it's de rigueur in French and physics. It's the way I think of it is what cannot be further simplified. And here's another version of this. Physics is the law, everything else is a recommendation. So the comparison would be traffic is heavy, I wonder why. This opens an inquiry, not closes it. Physicists all use this. Quantum mechanics came from a very simple first principles reasoning of a two-slit experiment, very simple experiment that particles must in fact be waves in their nature. Chefs make new recipes, knowing the properties of foods, and macro analysis, which I tend to be much more confident in, look at broad economic patterns to see what's going to happen. It supports innovation and creativity. It works on all time scales. It's strategic. It's necessary for strategic thinking. One can reason forward. For example, this guy, I'm sure you know who he is, looked at an experiment that said the speed of light in vacuum was a constant, and it was a sufficiently well-done experiment that he believed it. And from that, he developed his famous equation I'm sure you're familiar with. Mass equals Lagrangian divided by c squared. Oh, you don't know that one? This is how it became, this is what he wrote. This is how it became popularized into this. He never wrote this. But children do it. Time to go to bed, why? Because it's bedtime, why? But it's because you have to go to sleep, why? Because if you don't sleep, you'll die. Okay, I'll go to bed. So it's natural that way. It requires focus and mental effort. You got to think to do this. It takes time. And it can morph into dogma. And that's what I fear sort of Elon Musk has done with his first principles of freedom of speech and the two amendments. He's taken something that's not a first principle and cited it as such, and it became dogmatic. Comments or questions? We okay so far?
Okay. Yes, I put it in the chat room. Previous slides, when you put the image of your friend who really said that most of it's socially related, you never mentioned his John. You never mentioned his name, and if you would put the, I'm sure someone in the audience immediately will ask and
I'm doing it quickly because you guys are the audience. I would definitely slow down and talk about his name. Thank you.
Yeah, just put it on the slide because people might ask who he is and.
Well, the feedback I got last time was don't put names on the slide of people that don't know who they are. Remember from Dorinka?
I guess for someone it's a different audience. For someone like me who, if I would listen first time, I would just be curious who that guy is.
I think I'll definitely put the name in print, and I think this is a scientific audience. I think most people, I think most people will know who that is. But I'll take that. That doesn't hurt. I'll do that.
Yeah, and Charlie, I love how you using the children's why as an example, but you might want to really use that explanation for the previous one when you said that Janka said Friday afternoon it will be traffic. So you might want to just say how because she does it, she doesn't use the first principle when she
No,
says
that's
it.
reasoning by analogy example.
Yes, exactly.
So
So
that doesn't have the why.
yes, but you might want to use one or two examples that people would really easily relate when you switch to not reasoning by analogy, but going to the first principles. Something that people say, "Oh, I can do that."
Like what?
I didn't know. That's the question.
I thought people could relate to riding in the car and wondering why traffic is heavy. You can't relate to that idea?
No, I can. Yeah, but when you Nat, can you translate from my mumbling to what I'm trying to say if you get my message or my point? But just to really have a little bit easier illustration on
Well, this whole thing is about illustrations of this. This whole talk is illustrating this over and over.
all right.
I'm trying
Yeah,
to, I'm trying to teach vocabulary here, that's all.
Okay.
yeah, I'm not quite sure, Larissa, how I would change that. So let's keep going, and then maybe at the end we can.
Yep, okay. So the storylines is the second big idea. A narrative about people or events, true or fictitious, with the intent of informing or persuading, usually persuading. I'm going to define truth as that which is unarguable. The storylines are a self-talk. We all do this. Their thoughts and their expressions that seem true to us, and we would swear on the Bible that they're true if we had to, but they're not the truth because they're arguable. We willingly adopt hierarchical leaders' fictitious storylines because, one, we want to believe them, and or two, if not, they or the group will punish or reject us. And all you gotta do is look at US politics to see this in action. And the most interesting thing to me is how fictitious storylines, when they're adopted by groups, we embody them in ourselves and believe they're our own. Now you can watch the people who talk about the erroneous things that certain politicians say, and they believe they've thought it up. They believe they've figured it out. This is one of the most fascinating aspects of the human condition to me. Comments or thoughts? Can you relate to this?
Sure.
Let's take a look at the launch of a Space Shuttle Challenger. At the time Hubble's launch was 6 months out, I was sweating bullets. I had just come home from Marshall, having refused to sign the shipping authorization to Kennedy, and the room went nuts when I did this. They said, "We always sign it," and I said, "Telescope's not ready, operations isn't ready." And by the way, Marshall Space Flight Center, if you're not familiar with it, is one of 8 NASA centers, founded in 1960 in Huntsville, Alabama, and managed by Germans from Peenemünde, with von Braun as director. All the top jobs were Peenemünde people. And although rocket propulsion is its specialty, it also managed Hubble. And I went out to Goddard Space Flight Center, which is where that morning, which is where the operations for Hubble would take place. Another NASA center founded in 59. The specialty is robotic spacecraft. There's a strong science staff. I worked there for almost a decade. I pulled in the parking lot in headquarters where I was working at the time. People met me at the elevator and told me Challengers exploded. And the reason they met me was I had a Spartan payload, a reusable little satellite in there. Little for the shuttle world's 2,000 kilograms, 5,000 pounds roughly. It was to be deployed, and it was an effort at an ultra low cost payload, trying to find ways to fill the shuttle. It didn't take too much money. And I wondered if we'd gone too far on the low cost side. The structure was one I had gotten from in a deal with MBB in Germany, and I thought, could this thing have failed? If it did, it would have brought the whole thing down. So I went back to my office, cleared my calendar, turned on the radio, and they had Mozart's Requiem playing on NPR. Went home that night, and my daughter said, "Are you going to get fired for this?" Because all my children watch this on TV in schools. Of all things to blow something up, all the US kids, maybe the world, watched it because the teacher in space was there. And I said, if my satellite did it, for sure, but if I had nothing to do with it, probably not. Well, nothing to do with my satellite. The shuttle was covered with ice. It was a very unusually cold day. My friends and colleagues launched anyway. And the flight was going normally until it got to what's called maximum aerodynamic pressure. And you would have noticed this by the voice go at throttle up, which means go back to full power. We're through the worst of it. The shuttle got a very unusual jolt, kind of like turbulence in an airplane. And the first O-ring had already failed. It broke the second one loose. Hot gas came out of this solid rocket motor. The tank has got liquid hydrogen in it. There's still some atmosphere around. The hydrogen exploded and blew up the shuttle. So that's what happened. So what caused this? Was it technical abilities or social context? So social context is a term that I could spend half an hour on, but I'm not. Give you some sense of it. Simply put, it's the social environment shaped by most powerfully by collective behaviors of the group. So the question is, what are the group's behavioral norms that will set the social context? Is the social behaviors that are normative, habitually appreciating or relentlessly criticizing? Do people live in integrity or casually break agreements? Do they address unfortunate realities or ignore them? They take effective actions or go into the drama states of blaming or complaining. How are we doing so far? It's a quick tour into this. Okay.
Yep, this is good.
So what's your bet? I watched this on C-SPAN, the Failure Review Board, and one of my personal heroes, Richard Feynman, the great physicist, took the Roman material, put it in his ice water, and showed that it stiffened. And he said, I think we may have found the problem. So I said, okay, it's a technical failure. My colleagues who decided to launch didn't have data on this enormously out of norm temperature, and so they didn't know that the O-ring would stiffen like this. So it was a technical error, and unfortunately, that was the wrong answer. Some years later, I'm at University of Colorado, and one thing I learned there is every lunch with an academic gets a book recommendation. So someone said to me, you got to read this Challenger launch decision when they heard about my involvement with it. I'd never heard of Diane Vaughn, who wrote this book, or she was made a member of the Failure Review Board. And she said the important question was, why did they proceed to launch all the data suggested otherwise? What? They had the data and they didn't act on it? How could this be? This was like shocking. I know these people. They're good technical managers. She said the behavior was that they required ever stronger technical arguments to delay a launch than continue. And she coined the term for this. I think it's original to this work, normalization of deviance. You may know this as the frog and boiling water story, where things happen gradually, you don't notice them. The social context was NASA management had enormous pressure to launch. This is the Launch Control Center at Kennedy Space Center. The people in here all decided that they had to proceed to launch despite ice being on this. And what happened was that because of this enormous pressure, they berated the contractors to where the contractors agreed to go because it's a power differential. When government people push on contractors, they tend to yield. So to understand what really happened, I think we need to turn the clock back to 1971. NASA abruptly canceled the Apollo program, Apollo 18, 19, and 20, because every mission had near catastrophes. I call them diving catches. And what they realized was that if they continued to launch and it had another major accident, it's going to erase all the accomplishments so far of the sort of 11, 12 years of getting ready for this. So NASA needed a new reason to exist. NASA was formed for Apollo as a contest with the Soviet Union, but NASA never saw itself that way. It saw itself as being the cutting edge of space exploration. Yet, despite that reasoning by analogy, to go forward, they chose something that was analogous to what they'd already been doing. Marshall built the Saturn V launch vehicle. They wanted a big booster. Johnson built the Apollo capsule. They wanted another human thing. And I think the reason for this is people like to do what they know how to do. This is a crucial juncture in NASA's history to make that decision. So the Office of Management and Budget got involved, and they said if you're building a shuttle, then it should be a classified. It should carry all the U.S. payloads, including the classified and military payloads. And the thing NASA was thinking about at the time, X-15 was a little human thing, almost like a little airplane. They said the cargo bay's got to be bigger, so NASA complied with this. And the reason that they wanted this particular size was to launch the spy satellites, the keyhole satellites, classified at the time, that were this same size. They had been flying on expendable launchers before. So now NASA's plans are set. Administrator Fletcher goes to meet Nixon in the San Clemente White House, shows him the model and says, that's what we want to do. We want to build a shuttle and a space station. Nixon looks at it and says, pick one or the other. So NASA chose the shuttle because he must have reasoned that the space station didn't make any sense without a reliable way to get there, and the launchers at the time were not man-rated. Now NASA needed a reason for it. And reasoning by analogy, they developed this core fictitious storyline. The shuttle has pilots like an airplane, flies like an airplane, lands like an airplane, is safe like an airplane, usable like an airplane. We're going to fly 50 times a year, going to provide cheap access to space. This became the guiding mantra of everything going forward. And here it is with, so they also figured out pretty quickly that you can't, there's not enough money to build 50 payloads. Went to Europe and got them to build this thing called Space Lab, which is a reusable thing with a manned module and some pallets for instruments on the back. And the idea was you could put this in, fly it up, come back, take it out, refurbish it, put it in. That's how they got enough payloads. So because they provided cheap access to space, that was the cornerstone of this logic. How do you figure the cost? Well, NASA's budget is more or less fixed. It has been for many years, and the part that goes into the shuttle is about 70%. It's fixed. So what you got to do, the only variable you have is the number of flights. So it's got to fly more often. And they wanted to get up to that 50 flights a year number that Fletcher had put in place many years earlier. So let's look at first principles here. NASA is a government, congressionally funded organization, and jobs matter. So this is a reality. The Southern Senators Marshall and Johnson had powerful congressional constituencies. You're going to have to find jobs for them. NASA came into existence as a geopolitical imperative, not exploration. It was formed to take a bet on with the Soviet Union. And I think arguably one of its most important contributions is inspiration, particularly young people. I think anything inspires people to go into STEM as maybe as greatly as NASA does. It inspired me. I think exploration is embedded in the American psyche. We're mostly migrants here, or immigrants if you prefer, and we are certainly aggressively explored the Western frontier. Unmanned launchers are cheaper, plentiful, versatile, and reliable with multiple suppliers. You don't need a new launch vehicle. Humans add a lot of burden and little value to the launch process. I think that's a first principle. The orbiter is 150,000 pounds dry weight. Taking that to orbit with a 30,000 pound payload in it is limiting and inefficient. I think that's the first principle. Human physiology is the limiting factor in space colonization. We're not adapted to low gravity or the intense radiation. All kinds of things happen in low gravity. You lose your eyesight. Apparently, the most recent data, your kidneys fail. So what you need is a way to, if your goal is exploration of leaving the Earth ultimately, you really need a big program of physiology. The reuse was very problematic. The original idea was the main engine would stay on the shuttle just like they do on an airplane. After a few flights, that wasn't the case. They had to be taken back to Stennis Space Center to be refurbished. Look at the size of these things. There's people there, okay? There's 3 of them on every shuttle. This is gargantuan. The boosters were hot aluminum dropped into salt water, picked up by Coast Guard boats, had to be taken back to Utah for refurbishment. The tiles, which were, all this is really clever technology. The tiles which keep the bottom from burning up when it re-enters. You may remember Apollo had these flashes of light coming off when it re-entered. That was a rubberized ablative material. They wanted this to be something permanent, but what happened is damage happened from ice or runway debris or whatever. And it turned out every tile had to be custom made. This is a serial number. There was no, like this tile could go in one place only. And early on, they had to bring people from California to measure and retrofit these things. The reason I know this is that we had a launch delay in one of my early missions because the Brevard County Police rounded up the people from California. They were sitting in their hotel smoking pot, put them in jail. And NASA had to go get them back out of jail because that's what they were used to doing in San Francisco, apparently. Launches were frequently delayed as you need good weather in 4 locations. The launch site, the main landing site, Kennedy, the backup landing site, Edwards Air Force Base in California, and a transatlantic abort site in Africa. So you had good weather in 4 locations to fly. The loss of mission rate was not 1 in 1,000 as NASA claimed. You've got to turn to real data. For Challenger, it was 1 in 25, Columbia 2 in 135. Data are first principles things. Data cannot be argued with. They're first principles. As for safety, Jake Garn, who flew on one of the early shuttle flights, was a senator from Utah. He was asked, "Is this dangerous?" He said, "Anything that requires removing everybody 3 miles away before you do it is likely dangerous." Which I thought was pretty funny. Low Earth orbit, the highest the shuttle can go is 400 nautical miles. That's not a very optimal orbit. And by the way, this is what it's like. You're right against the Earth, just like this picture. About the only thing that's good for is the space station, which is the shuttle's original purpose. It's horrible for an astronomical telescope like Hubble. If you put it into high Earth orbit, it's 4 times more efficient. That is to say, it gets science 4 times faster. Space lab flights were also good for this orbit, but only 2 weeks. And it turned out the science was very limited. Science you can do in microgravity is not that interesting. And a couple astrophysics things were flown, but it quickly realized that this doesn't make any sense. You need years for these kind of measurements. Most payloads accordingly require an upper stage. So now you've got the shuttle carrying a payload and an upper stage in it. Launch delays are very costly for payloads, so trust me on this. What you got to do is you got to keep the engineers around that built these payloads to troubleshoot things that might come up as you get near the end. And keeping, we call them marching armies, very expensive engineers in aerospace. The vibration is something called POGO. Liquid engines have this pulsing, and these are much worse than expendable launch vehicles, much harder to design for, because the shuttle main engines are right next to the payloads, whereas the expendable launchers, they're all the way at the end. Loads have to be taken into these trunnions on the side instead of actually much easier with expendable launch vehicles. And contamination was a problem. The shuttle interior was only visibly clean. These cloth panels opened up to the landing gear and mechanical stuff for the shuttle. So it wasn't like you could have this cowling at the top of an expendable launcher that was class 100 or class 10 clean. These are all the problems of the thing. So what did NASA do? They say this is a bad idea? No, they first doubled down by flying celebrities. Jake Garn, I mentioned, Congressman Bill Nelson, who's now administrator of NASA and the teacher in space. Then Beggs went all in on this. Let's make it the National Space Transportation System. He had personal access to Reagan, who made this decision for him, with him. And it outlawed all expendable launchers. If they had just said, use the shuttle if it makes sense. I think things would have been okay, but he got them to say, you're gonna have to use the shuttle, even though you can see it's not very opportune. And the three-letter agencies were hopping mad, understandably so. They were accustomed to secret launches. You didn't hardly knew they were even happening. Now a shuttle launch is a very big public event. They got them whatever they wanted them. The launchers were at their service, and the shrouds were completely clean. And now they needed to redesign the payloads to take these new loads, to take the loads into trunnions. So they banded together and exercised their considerable national security clout. I'm sure they played national security card. Here's some of them: the National Security Agency, National Reconnaissance Office. The CIA has a space program. And they installed Bill Graham as Jim Begg's deputy. So they went to the White House and political appointee, you get who they give you. Then they claimed that Beggs broke laws when he was back at General Dynamics. It's called concurrency violations. I'm not going to take the time to explain it. Yeah, I will during the Q&A if you want. It was trumped up charges, forced his resignation. And of course, once you resign in Washington and you go through the courts and get your own lawyers, everybody forgets about it. So if you want a friend in Washington, get a dog. So frustration reigned as the schedule for Challenger had slipped 6 months and then day after day slipping. And the current launch rate is less than 10 a year, not 50. By the way, amazingly, think about this. Apollo flew 9 lunar round trips in 3 years. Compare this to where we are now with the shuttle. Bill Graham is now in charge. He had no interest in policy or management. He's in my office all the time. He wants to know about gamma ray astronomy and the Big Bang and things like this. He made speeches in town at luncheons and talked about thermodynamics of an airplane wing or something. Turned out he had a lot of political clout. He'd been an advisor to candidate Reagan. Remember the transition team? That's how he got the job. The day before the launch, ostensibly, the White House called and said Reagan wants to teach me in space tomorrow for a State of the Union. So Challenger launched and was exploded as I described. So Reagan made a different speech than he thought. He made a very a memorial speech to the loss of the Challenger crew instead. So let's fast forward to 1993. I'm in NASA headquarters. I'm now director of strategy. And I had a group I worked with, the 40 top managers in NASA, and I made a presentation called The Space Shuttle, a Technological Marvel and Policy Failure. This got people jumping on their feet and shaking their fists at me. The next meeting, they apologized. And I called this a mission, what we were doing, mission to infrastructure. So let's cancel everything that does not tie directly to a stakeholder need, for example, the taxpayers, and advocate a vision of human exploration, the moon and Mars, with infrastructure to follow. So see what I've done here is made the infrastructure a consequence of exploration, not the other way around. Now that you could have a small shuttle or a small station to study physiology. I think that is the key to learning to live in low gravity to any of this, if that's what you think you want to do. Charge Marshall to develop unmanned launchers for landing on the moon and Mars. Robots and equipment first. I would put the infrastructure again now on these places before humans go. Reusable launcher. Maxwell Hunter, Lockheed employed, detailed the DCX, a reusable launcher in 1985. SDIO actually built one and operated it and turned it over to NASA, who canceled it. Charles Johnson Space Center developed an evolutionary laboratory to study physiology and maybe a long duration orbiter. There was an idea of a 25 kilowatt power source to plug the orbiter in to give you months of orbiter time, and or a small human research oriented space station. And Jet Propulsion Laboratory had been landing on Mars to begin placing large infrastructure. And my idea was to have something like a habitable structure that robots could live in and operate, and find a way to drill into the surface and get water, do all that, and put fuel for return flights home, and do all this before you put humans there. Instead, NASA was focused on what they called a permanent presence in space, which was a space station, which in my mind was even a bigger folly than the shuttle. So I said, enough of this. I left and went to CU in 1993. So, and that's what they continued to do. So if they weren't gonna, I reasoned that if the head of strategy couldn't buy into NASA's biggest program, he shouldn't be in the job. So I departed on my own will to do this. This Columbia disintegrated in 2003 and the flights totally ended in 2011. So it's easy to be critical in hindsight. High-level government jobs are demanding and complex, as anyone who's had one can tell you. This is my storyline about Challenger from Diane Vaughan's book. It is unfortunate the sociological explanation is the correct one, as these invisible and unacknowledged forces elude remedy. I've argued that reasoning by analogy is root cause, that they did something analogous to what they've done before, analogous to the Saturn V, analogous to the Apollo module. And that's the root cause. Promulgating a fictitious storyline, shuttle provide cheap access to space that drove everything. The fact that organizations become more bureaucratic as they age might be even a deeper root cause. Let's look at another example, Hubble's flawed mirror. How are we doing so far? Okay. This was the early slogan of Hubble. I had this coffee cup in my presence that burned up when our house burned down. So Noel Henners was the associate administrator for science, and NASA had been studying the Large Space Telescope. He quit the program in favor of what he called the Space Telescope because he had the clearances to know that the KH-11 shipped in the Lockheed C5 Galaxy shipping container. So if you could build something the same size as that, and that's an expensive thing, a shipping container. This is a non-trivial matter to ship sophisticated space hardware. It's got to be power, clean, air conditioned, and fit in this airplane. He managed to get a new start from Administrator Fletcher, almost surely because on-orbit servicing helped the shuttle make sense. So this is a byproduct of the shuttle as a cargo thing. Reasoning by analogy, the storyline was just an optical telescope in space, how hard could it be? And that drove every element of the program. And what the reasoning was that it's very similar to a keyhole satellite. It's the same size. It's got the same size mirror. It's the same optical design. They've been flying those since the 70s. They popped these out. So this is going to be easy. And perfecting optical telescopes are household items. You can buy one for $500. So this looks like a piece of cake. So I want to talk about why you do Hubble. If you go to a place where it's really dark, and the Great Sands National Park in Colorado's got a big award for this. Go out there on a clear night when the moon's not around. Look up, you'll see the stars quite brilliantly twinkling. They're not changing their intensity. What's happening is variations in the air density above you is refracting the light and making it switch on and off of your retina. It takes what should be a point of light and makes it a big gray blur if you put a large detector here. So Hubble's benefit is it's above the atmosphere. In order to realize that benefit, it's got to be very stable, just like you hold your camera stable when you take a photograph. What's the number? It's 7,000ths of an arc second, and you're going to take long exposures, so it has to do it for 24 hours. That's the angle that a 10mm pearl makes the distance from Washington, D.C. to New York City. This is an incredibly hard thing to do. If you do it, instead of that sort of gray, blurry image, you get this high contrast, bright image. And the way Hubble sees farther and deeper than ground-based telescopes is it concentrates the energy in this point. It basically improves our seeing by a factor of 10, which is going from 2200 vision, which is legally blind, to 2020. So if we miss this spec by a factor of 10, this wouldn't happen. And that's a hard spec to meet. We still would have built the most precisely pointed thing that anyone ever made, but Hubble would have been a total loss. The keyhole does not have this problem. The keyhole takes little snapshots of a bright Earth. This is one of the design things. Marshall had recently managed these high energy astronomy missions. So very similar to Hubble, it's also easy. The analogy was not good. That program had experienced space scientists, an excellent prime contractor, no daunting requirements. I actually worked on that as a scientist. Marshall has no suitable in-house scientists. So the argument was they could just hire one to move to Huntsville, Alabama. Well, how many top ground-based astronomers want to move to Huntsville, Alabama, do you think? University ground-based science do not know and don't like NASA. They're blue personalities. They're very freewheeling. They don't like the idea of the kind of controls NASA puts on things. Their Germanic management style worked for Saturn V, so it'll bring needed discipline to the project. There's no analogy between what you need to do to get contractors to build a booster and scientists to build this. And probably the biggest mistake, they didn't have a mature design because they've been studying a different telescope. Get good numbers for cost estimating relationships. That set the budget in stone. Cost increases exponentially with complexity, not linearly. These were all the mistakes they made, continued reasoning by analogy. It's okay to yield to the classified community's demand for PerkinElmer, because Lockheed Martin, to have no prime contracts, because Marshall will do system engineering. Marshall's core competency is propulsion. They have no knowledge about this kind of complex optical system. This whole string of rationalizations flowed from one thing. How hard can it be storyline that flowed from reasoning by analogy with the KH-11? Also known this as wanting to believe your own, and you can assert the word yourself. We willingly adopt hierarchical leadership storylines. We want to believe them. This is true. Everybody wants to believe it's easy. So what would an effective Hubble organization look like? I asked my good friend Tom Young. We were both waiting to make a speech at a conference. He's probably NASA's most revered project manager. What matters most in project management? Here's what he said to me. For everything you care about, one ass to kick and one neck to wring. This is the way I organized other things. So I'm going to give this color code of blue. Think of blue sky thinking. Orange for process. You can think about how the orange sun organizes the solar system. And starts with the administrator, who mostly deals with members of Congress and the White House. This is the organization. Associate administrator, in this case, other agencies. Me, with the money and the requirements. I'm the managing entity here. I put this at Goddard. It's got the in-house scientists for this. They would have a science working group that the community would respect. And the Lockheed Martin, probably the same contractor for spacecraft system engineering. They system engineered the KH-11. They're a big system engineering company. PerkinElmer as their sub. Instruments over here. End of story. Goddard does operations and servicing. It's just another organization within Goddard. It's their core competency. Everybody's doing what they do well. What did we get? Well, we got the administrator, associate administrator, and me. That was the same. They put the job at Marshall, as I explained why. They had no in-house scientist, so they brought a guy from outside who was not a NASA person. They immediately had strife with the science working group. They agreed not to have a prime contractor, so they had Marshall doing the system engineering in-house. They couldn't do it. Later put it at Lockheed Martin, who couldn't do it. They weren't in control of PerkinElmer. I fixed this in later years, by the way. PerkinElmer had a complete mismatch of culture with this process-oriented Marshall Saturn V thinking, this highly innovative, state-of-the-art optical systems. They agreed with the Congress and gave ESA the solar arrays. You never, ever give a third party a system element. I have no idea why they did that. I tried to change that and couldn't. Goddard got its own project office, and they didn't get along with Marshall. They didn't like each other historically. And they built the instruments and integrated the instruments and built a whole separate facility at Johns Hopkins University because of the bad ill will with Marshall and the science, running an independent science institute. Can you believe this could do anything? That's the reality that I walked into. And Goddard doing operations. So the recurrent cost overruns, an attempt to live within this nonsensical budget by pressuring contractors, posing draconian D-scopes. At one point, Marshall advocated launching a telescope with no instruments and putting them in later. An atmosphere of strife everywhere. Everybody's miserable. And we had these quarterly reviews at Marshall with hundreds of people, and everybody smiled, everything's okay. It's what I call a looking good family syndrome. So 13 years and $2 billion later, we finally launched. And I was greatly relieved that went well. The solar arrays got stuck on deployment, just as I imagined. I had tried to get ESA to change these. They refused. They're still mad about Space Lab and the fact that we promised them 50 flights a year. We managed to jury rig it, get it to work, and the telescope came out. So I go over to 6 weeks later to the first night, and we open the door, and this image shows up on our computer screens. Everybody cheers. I turned to my chief engineer next to me, Gene Oliver, and said, Gene, those images are blurry. He said, don't worry. This is an adjustment we can make. We planned for this, no problem. So I'm happy. Next thing we find out is we got a mirror. This is a nearby galaxy M100, Messier 100. This is what a ground-based telescope can do on a really good night. This is the best Hubble can do. I'm literally arguably responsible for the biggest screw-up in history of science. Right after this, Barbara Mikulski, the head of appropriations for NASA, summons me to her office, and she's mad. And the reason that she's mad is that she asked me a year earlier, is the telescope going to work? What would you say? Could you say maybe? You say, I don't know. Of course it's going to work. I didn't know it's going to work because of that pointing thing I showed you earlier, but I said that anyway. So she takes and puts her finger in my chest, spitting and screaming at me. There will never be an appropriated dollar to fix this telescope. This is a nightmare, it has to go away. The administrator truly is with me, the two of us in the room with her. I've never seen him looking mad, so I had to make this up this way. Get this car to go back to headquarters. He turns to me, this is the head of NASA. Charlie, you heard the congresswoman. Yes, sir. So I go back to my office. What's the only way out of this mess? Well, it's going to have to be fixed. There's no other way. So who has the resources and the will to do what has to be done? So I thought about this quote from Admiral Halsey. I went to my senior year of high school to a private school mostly taught by retired admirals. He said, there are no great men, just great challenges that ordinary men out of necessity or forced by circumstances to meet. So I'm forced by circumstances. I've got to defy both the administrator and the head of our appropriations. I got my budget analyst in, said, take $60 million out of the program, put it into a secret account. I brought my staff in, told them I took 10 million from you, I took 8 million from you. They would have gone crazy if I'd taken 50 cents from them, but they looked at my face and said, then no one said a word. So what's happening now is we're back into the development program. NASA's increasingly frustrated. We go back in time now back into the development. How this happened. NASA was increasingly frustrated with the current overruns at PerkinElmer. And reasoning by analogy, NASA management said, if I express enough anger, I'll motivate them to do better. What's the analogy for this? I think probably high school football or something like that, where coaches yell. Reasoning first principles, the right thing to do would have been to wonder, what's NASA's role in creating the mess? Because NASA set the budget, picked the contractors, gave them statements of work. You think that happened? Yeah, good luck. Okay. So what PerkinElmer was doing is they're making Kodak's mirror perfect. So to have a perfect telescope, we took these blanks from Kodak and with computer controlled polishing, improved them. NASA said, if you fail to complete the mirror on cost and schedule, we're going to fly Kodak's mirror in your place because it was good enough. And we're going to tell the world you couldn't build a 94-inch mirror. This would be an insult to PerkinElmer. And of course, this was a big power differential. So they panicked, got a text, said, go get that mirror finished. So he's working late at night. And this was the device used to figure the mirror. It's called a null corrector. It's got two mirrors and a lens. All he had to do was respace it. So reasoning by analogy, he assumed non-reflective tape would be just as good as the paint he's supposed to use because he couldn't find the paint. So he put this tape on top of the cap on the Invar rod. If that had been normal business as usual, he would have been flagged for violating a written procedure, but nobody was there but him. He didn't notice that a piece of the paint chipped off. The tape chipped off when he cut it with his X-Acto knife, leaving a bare spot of aluminum. So he adjusted to a bare spot on the cap, not the rod. So this is what he's supposed to do, put the cap and focus down on the rod. Happened to hit a shiny spot here and focused on this instead. So we attached the field lens on the bottom, which was in a pre-fitted bracket. It wouldn't focus. So we added spacer washers until it did. This also should have rang alarm bells. This is a prefabricated part. Again, late at night, the Cogs engineers left for the day. He never followed up. We found him in Kennedy and retired in Florida and talked to him. That's exactly what happened. The third mistake was that you required this polynomial expansion called Zernike polynomials to measure the radius of curvature at the center of the mirror. Well, it's an imaginary measurement, and the null corrector with the mirrors had a hole in the center of the mirror, so it couldn't do it. They got a different refractive null corrector, meaning using lenses, and measured the mirror. It showed half a wave of error. So the techs looked at the instrument spec sheet and saw the precision was half a wave. They never checked if PerkinElmer, who'd manufactured this null corrector also, can make it that imprecisely. If they'd asked, they would have said, yeah, that's the spec. We don't work the way we work normally. It'd be much better than that. That's just the spec sheet. That's the third mistake. The primary mirror was coated and put in the flight mount, and it was the only tangible accomplishment the program had. And now we're like 6 years in. So it was proudly displayed. It was behind glass, and you could go, they showed it to me every time I went there, and techs were walking around. They measured repeatedly to confirm nothing had changed, because you just want to see a consistent result. It showed a half wave of error. Reasoning by analogy did a calculation that treated the glass like a liquid. It's erroneous. They adjusted the parameters in the calculation, which is very difficult till they got the answer they wanted. This is called confirmation bias. So all these things are how we flew with a flawed mirror. How big was the flaw? Well, the error was basically zero here because it was the null corrector was misspaced out to a maximum of 4 microns across half of 96 inches. A human hair is 75 microns. That's how small the error was. I'm going to revisit the problem this created. So, do you reward people fixing problems they created? NASA, once I got the servicing mission moving, promoted me up to the top of NASA. I hated it up there. It's all politics. What to do. I mentioned before, I got moved in a sabbatical to University of Colorado, watched the servicing on TV at CU. It was completely successful. And that's an animation error I've got to fix. When my 2-year sabbatical ended, I chose to stay in Boulder and founded 4D Systems. And the irony here is after back-to-back Mars failures, NASA asked me for help with team performance. And over a 10-year or so period, I did trained 1,500 NASA teams using these processes. So the irony is I contributed more to NASA by leaving than I would have if I'd stayed. So summary, Challenger and Hubble failures had a lot in common. Marshall had managed both with a rigid kill the messenger style that came directly from the top, driven by fictitious storylines from reasoning by analogy in both cases. That the shuttle could be operated like an airplane, providing a cheaper, better launcher than expendable launch vehicles. Hubble was straightforward and could be completed within the cost derived by analogy. they pressured contractors to do things they couldn't do. Suppose in 1971, NASA ran the storyline, not from analogy, but from first principles. We are a human exploration agency, not a launch services agency. NASA would have continued DCX and have returning launchers many years before SpaceX. And a KH-11 derived optical telescope would fly high above the Earth, returning science 4 times faster than the normal closure. So what do you think, folks?
I like
found-
it.
Yeah, I like it too. I think it's very much on the point, and I think you will have a successful presentation.
Yeah, it's good, isn't it?
Yeah, it's very good.
Yeah, it's come a long way. It's great.
I thought it would interest you to see how much it improved. I still got a couple little things to fix in there. Thank you for doing this. But it's
Welcome.
a really good story, and I got it done in 55 minutes. So
Yeah.
I can do it 10% slower and do it on time.
Yep.
Yeah. Do you expect any questions? Do you expect the session to be recorded?
As far as I know, they don't record it. I
Mhm.
tend to ask them if I can bring my own camera and record it.
Mm,
Right.
But these YouTube videos get the message out probably just as well.
yeah, yeah.
Mhm.
I think it's a really good story now. It's tight, isn't it?
Yeah, yeah. It's very nicely polished, right on the point. There is no, yeah, I wouldn't change anything. I would just keep it as is.
Thank you.
Yeah, I
Thank
like the
you.
rearrangement. I like the added key for colors. I think that was really, really good. Yeah, I think, you know, having gone through this a few times now, you've really gotten it tightened up. And yeah, I'm kind of interested to rewatch this video and just kind of see if anything else pops out. I did note a couple typos, which I'll send over.
Okay. Well, by the way, I've got to put a really clean time junction when we're going back in time. I've got to put something in for that.
Okay,
And I've got a little animation tweaks I've got to fix.
sure.
But yeah, I'd love to hear about any typos. I think it's a print at this point. I mean, I tell Frank that each and I don't believe it, but I think it's there. I'm comfortable with it.